This lesson is for Mrs. Cucci's College Now College Prep class. Today we are on lesson 3.2 and we're going to be talking about linear equations in one variable and proportions. So as we go through this video, make sure to take the notes along with me and then do the practice document after. Okay, so the definition of a linear equation. A linear equation in one variable, we'll say x, is an equation that can be written in the form, ax plus b equals 0, where a and b are real numbers and a cannot equal 0, because if a equals 0, you'd lose that variable. Okay, so that's a linear equation. You guys are also used to seeing it like this, mx plus b. This is slope-intercept form, but that's linear as well. Okay. All right, so we're going to use properties of equality to solve the equation. And we're going to solve it and then check it afterwards as well. So when we're solving an equation, essentially what we're doing the opposite of what we were doing with expressions, and we're going to work backwards in the order of operations. Okay, so we're going to undo subtraction and addition. We're going to undo multiplication and division. We're going to undo exponents in parentheses. So the first thing that we run into is we know we want to get this x here by itself. Okay, that's the goal, get this x by itself. So we need to move everything away from it. So starting from right to left, we're going to undo addition and subtraction. So I have addition here. To undo it, I subtract. And I get 2x equals 14. Next, I still have to get this x alone, so I need to undo that multiplication. The inverse of multiplication is division, so I'm going to take and I'm going to divide by both sides by 2. What you do to one side, you must do to the other. And you get x equals 7. Now we're going to go through and check that. And how we check that is by simply substituting it back into the original equation. 2 times 7 plus 3 equals 17. Now the left-hand side and the right-hand side should equal another if I'm correct. 14 plus 3 equals 17. 17 equals 17. Check. Okay. So when we go to solve linear equations, again, we're simplifying the algebraic expression on one side by removing, grouping, symbols, and combining like terms. We're going to collect all the variable terms on one side and all the constants on the other. Then we isolate the variable and solve, and of course we always want to go back and check. All right, so let's try this one. Okay, so in order to solve this one out, we are going to have to get rid of these parentheses. And we know to get rid of these parentheses, we have to use that distributive property. And we're going to go ahead and distribute through that 2. Our next step is to go ahead and combine my like terms. And I see my like terms, I have to have the same variable, right? So here are like terms here. And it's always on one side of the equal sign. You're only combining like terms on one side of the equal sign. You're not combining from one side to the other. 2x minus 5x, negative 3x, minus 8 equals negative 5. Okay, so next we need to isolate the term that has the variable. Isolate means to get alone. That means I have to move this negative 8. So we're going to move that to the other side. So 8 minus 5, or negative 5 plus 8, is positive 3. And then we're going to go ahead and divide by negative 3 to get that x alone. And this gives me negative 1. And I do want to go ahead and check that back into the original. Okay. You do what's in the parentheses first, because you're evaluating an expression here, right? This half is an expression. So 2 times negative 5 minus 5 times negative 1. Now we do the multiplication. Negative 10. Negative 5 times negative 1 is a positive 10. Positive 5. Went a little crazy there. Sorry. And negative 10 plus positive 5 is a negative 5. So that checks. All right, let's keep going. So now we're getting into something a little bit different. If you notice, I have variable terms on both sides of the equal sign. So it's my job now to move all of my variables to one side and all of my constants to the other. Constants meaning just the number terms, right? You want to move the term that is smaller, okay? If I were to take this 8x and subtract it over, I'd wind up with a negative value. I don't really want to deal with negative. So if we take and move the smaller term, we wind up with a positive value. Okay? And since I moved the x to the right-hand side, I want to move the constants to the left-hand side. They're always going to go to the opposite direction, or the opposite side. Negative 12 minus 24. If the signs are the same, you add them and keep the sign. And then one more step in isolating that x is to divide by the 3. And we get negative 12 equals x. And of course, you do want to go back in and check it, back into your original. Okay. 5 times a negative 12 is a negative 60. 8 times a negative 12 is a negative 96. Negative 60 minus 12 is negative 72. Negative 96 plus 24 is also a negative 72, and that checks. Okay, let's try another one. So we're going to go ahead and distribute. We're going to distribute in both locations. Okay, so we get 2x minus 6. Don't forget my minus 17. You're going to distribute through the negative 3. Notice it's got that minus in front of it, right? So negative 3x minus 6 on this side. Now we're going to combine like terms on each side of my equal sign. Okay? On each side of the equal sign now. So 2x. Signs are the same, so you add the numbers and keep the sign. Minus 23. Negative 3x, right? And 13 minus 6 is a 7. Now we want to move all the variables to one side, the constants to the other. Again, you're moving the smallest value. Is 2x smaller than negative 3x, or is negative 3x smaller than 2x? That's what you need to decide. Okay? Remember, negative numbers are always smaller than positive numbers. So we're going to move this negative 3x. I'm going to move it over by the opposite operation, which is going to be addition. So if I'm moving the variables to the left-hand side, I need to move the constants to the right-hand side. And then my last step in isolating is to divide by that 5. And you get x equals 6. Okay. Let's get a little bit harder. Now we're going to start getting into some fractional values. Okay. So, what you want to do for these ones is you want to get rid of these denominators. You don't want to deal with fractions. So the easiest way to do that is multiply both sides by a common denominator. Okay? The easiest way to find a common denominator is to take the denominators that you currently have and multiply them together. 2 times 5 is going to give me 10. So if I take now and I multiply both sides by 10, you're going to see something interesting happen. All right, you got to distribute. Okay. You're going to see some reducing happen. Okay. 2 goes into 10 5 times. 5 goes into 10 2 times. And now we can go through and finish multiplying. 5 times 3x is 15x. 2 times 8x is 16x minus 40. Okay, so I've just made it a lot easier for myself. Move the smaller one. It's going to leave me with 0 equals x minus 40. And we add over that 40. You get 40 equals x, or x equals 40. Okay, so that's how you get rid of those denominators so you don't have to deal with the fractions. All right, so let's take a look at an application problem now. Responding to negative life events. So a study was done to rate the sense of humor of 2 separate groups. From this data, 2 equations were derived. We've got low humor group, which is D equals 10 ninths x plus 53 ninths. And low humor group, D equals 1 ninth x plus 26 ninths. This should be high humor group. I apologize. Let's fix that. Okay. In each formula, x represents the intensity of a negative life event, from 1 being low to 10 being high. And D is the average level of depression in response to that event. So if the high humor group averages a level of depression of 3.5 in response to a negative life event, what is the intensity of that event? So high humor group has a depression of 3.5. We want to know what the intensity is. The intensity is x. Okay, so we're using this equation to determine that. Now we know the depression is 3.5. Now we have to solve for x. Okay. So again, if you think about 3.5, I really don't like to have fractions and decimals mixed. So I can rewrite 3.5 as 7 halves. That might make it easier for us. Then it's really easy to find that common denominator, right? You take the 2 numbers, 9 and 2, and you multiply them, you get 18. Okay? So we're going to go through and we're going to multiply each piece of this by 18. Okay? So you're going to see those cancellations happen, right? Or simplifications, I should say. And we get 9 times 7, which is 63. 2 times 1, which is 2. And 2 times 26, which is 52. So that's a much easier equation to work with. Now we want to isolate this 2x, which means I want to move this constant term to the left-hand side. And then isolate the x. X is 11 halves, or 5.5. Okay? So the next thing we're going to talk about is proportions. Proportions, or a ratio that compares quantity by division. A proportion is a statement that says 2 ratios are equal to one another. So the cross products principle for products, so that what that means is if I have the proportion AB equals CD, then when we cross multiply, we would have AD equals BC, okay, where B is not equal to 0 because then it would be undefined, and D is also not equal to 0. Okay, so those are cross products. So it says AD and BC are equal to one another. So let's try our hand at some cross multiplication. Okay, so we're going to cross multiply, right? 63 times 5. equals 7 times x. $63 times 5 is $315. And that's going to equal 7x. And then we go ahead and solve for x by dividing by 7. So x is 45. And that's it. So now let's try it over here. Now this was a little bit different because I'm going to be multiplying a monomial by a binomial. Okay. So I'm going to have to remember in this case I have a little bit of an extra step to deal with. I am going to have to distribute here. Now I do have variables on both sides of the equation, so I have to remember I need to move all my variables to one side, all my constants to the other. I'm going to move the smaller, then move the constant, and then isolate. And that's it. Okay, so now let's put this into an application. The property tax on house assessed value is $480,000 is $5,760. That's their property tax. Determine the property tax on a house with assessed value of $600,000. Assume the same rate. So what we're going to do is we're going to build a proportion. Okay, if the tax is $5,760 for this house, we can say if it's the same rate, the tax on the next house is going to be proportionate. Okay, so we set up this ratio, right? So my tax for my original house and the house's original cost. That's going to be equal to whatever the tax is on a house that's worth $600,000. So again, you're going to cross multiply. And you're going to use your calculator. Okay. And then we're going to divide. And we wind up with the tax value of $7,200. All right, let's try another one. Wildlife biologists catch, tag, and then release 135 deer back into a wildlife refuge. 2 weeks later, they observe a sample of 140 deer, 30 of which are tagged. Assume the ratio of tagged deer in the sample holds for all deer in the refuge. Approximately how many deer are in the refuge? Okay, so we're going to do the original number of deer. And we're going to divide that by, this is of tagged deer. And this is going to be total number of deer. Okay. And that's going to be equal to number of tagged deer in observed group over total observed. So notice it's total on both in the denominator and number in the numerators, right? Okay, so the original number of tagged deer was 135 deer. I don't know how many deer we had to start with. That's what we're looking for, how many deer total. The number of tagged deer in the observed group, we had 30 out of a total number of observed deer of 140. So when we cross multiply, 30x equals 18,900. And then we go and divide by 30. We'll wind up with 630 deer for your total population. Okay, just 2 more examples. We're almost done. All right, so attempting to solve an equation that has no solution, this will eventually happen. Okay, so you have to know how to deal with these as well. So the first thing that should come to your notice is that you've got this right-hand side where you really want to distribute. So what you wind up doing is you go ahead and you distribute that out. Okay? Now you guys know that you want to get all of your variables to one side, all of your constants to the other. So when you try and do that, what winds up happening is you lose your variable altogether. You wind up with 6 equals 8, which you know obviously it doesn't. So when you have something like this, there is no solution. Okay? And you can write it like this or like this. Last one. Solve an equation in which every number is a solution. So this one's a little bit different. All right. So the right-hand side, I obviously want to do a little work too. So I'm going to go ahead and I'm going to distribute. And then on that right-hand side, I'm going to combine those like terms. Now at this point, you should notice that you've got 4x plus 6 is equal to 4x plus 6. Okay? The right-hand side is equal to the left-hand side. When something like this happens, your solutions are every single possible number that you could plug in. So your solutions are everything. So all real numbers. Okay? And that's that. Okay, so make sure that you get the practice document done, and we will be doing 3.3 tomorrow. Thanks, guys.